Let a geometric progression be AR power 2 and AR power n minus 1. Then the sum of n terms denoted by Hn is equals to A plus AR plus AR power 2 and then plus AR power n minus 1. I shall call this equation 1. Multiplying through by R gives Rsn is equals to AR plus AR power 2 plus AR power 3 and then plus now here I have AR power n minus 1 times R, and here R is power 1. Let's recall the rules of indices. If you have x power m times x power n, then the result is x power n plus n. So it means that this one is the same as AR power n minus 1 plus 1, which is AR power n. So here we have AR power n. I'm going to call this my equation 2. Now subtracting equation 2 from 1 gives me Sn minus Rsn equals A minus AR power n, from which Sn into 1 minus R equals A into 1 minus R power n, and Sn equals A into 1 minus R power n divided by 1 minus R. Thus, the sum of n terms of a geometric progression is given by this formula here. Now, this formula is only valid when the value of R is less than 1. Again, subtracting equation 1 from 2, I shall have Rsn minus Sn equals to AR power n minus A, from which Sn into R minus 1 is equals to A into R power n minus 1, and Sn is A into R power n minus 1 over R minus 1, and this formula is valid when the value of R is greater than 1. For example, the sum of the first 8 terms of the GP here, the GP is 1, 2, 4, 8, 16 and so on. The value of R here is 2, and that is the R is the ratio between two successive members of the series, so that the sum of the first 8 terms of this series is given by A is always the first term, which is 1, multiplied by the common ratio, which is 2 power n. N is the number of terms, which is 8, subtract 1, divided by 2 minus 1. This simplifies to 1 into 256 minus 1 divided by 1, which is 255.